Record on this computer. Okay, so let's go over one more time, or first time maybe, what we're looking at for model view controllers. Let's actually run it first, just to see it. Hopefully, let me know, unmute yourself if you're not seeing everything. All right, I'm gonna build my, I'm gonna compile everything. Hopefully it's gonna work. Here we go. So this seems pretty dull. That's a bit more exciting. Okay, I can make a triangle. That was me control clicking and then dragging. So I press the control key, click and drag, and I get a triangle. Control shift. This is what I made for the lab. There is nothing really crazy about, they're radically different things that I'm making in terms of shapes, except they all have the same fundamental DNA. They're all using a shape class. And by the way, I can make a whole bunch of these in case you're wondering. And when I hover over things, it changes color. The reason they all work a particular way is that they all follow what's called a model view controller approach. A model view controller approach means that I keep my data, the information I'm keeping about the shape in one place. I have a view, the thing that knows how to paint stuff or to draw stuff on the screen is a separate class. And the controller, the thing that handles mouse inputs, handles timing events, handles anything with a callback in the code. If I keep them separate, but I pretend that they're one unit, it's like the holy trinity of code, essentially. So I have a model view and a controller. They work together as one class. It's actually really three classes. So let me get, and hopefully that, you hear a sound of a leaf blower. Hopefully you don't hear that too much. So here is triangle.h. Here's what my triangle shape looks like, the one that actually works. I could have called it triangle model. That would have been probably better, but this is, I called it triangle 2400. Okay, I have a triangle view, and then I'm gonna have some other controller. So the triangle will have a model, a view, and a controller. I only needed to make separate triangle classes for the view and the model, not the controller. So let me look at shape 2400.h. Here is the parent class of everything. I have a model, which has information about the state of the shape that I'm dealing with. I have a view. So you'll need to refactor for other stuff. So my view just controls my paint. Here's what my view does. I could set the model. It has a pointer to the model that I'm to get myself data, and it allows me to paint and allows me to paint an outline. That's it. All it does is paint. And when it needs data, it goes, hey, model, give me the data. They communicate to each other. So the view knows about the model. The model doesn't need to know about anything. It just needs to store data. So the view goes, hey, model, tell me the size of the rectangle. Hey, model, tell me the color of the rectangle. Hey, model, tell me whatever bit of information you need. And then I have a controller. The controller handles things like, did I have a mouse event? Is the mouse going down? Is the mouse coming up? Has a timer gone off? Okay, and it too has access to a model. So it says, hey, model, what's your state? Are you disabled? Hey, model, are you this? Hey, model, are you that? It also allows you to tell the model, hey, by the way, update some stuff. So I could set my model, but here's more importantly, I can update the mouse. I can have a mouse event and handle that. And I could have called it a different name, but update time is when a timer event goes off. Okay, so for the shape class, I have a model view controller. One step out from that, I'll have a model view controller, and each one of those inherits from the other one. So the triangle model, the triangle 2400 extends from shape 2400. So I have a shape, and the triangle is a more specific version of a shape. I may have a circle, which is a specific kind of shape. I may have an animating rectangle, which is a particular kind of shape. Okay. So that's this 3-in-1 thing. You're probably wondering, how the heck does this work? Well, what ends up happening is the following. Let's see if I have the actual code here. This model view. This is my main class that has everything in it. You don't even need to look into this really, but let's look at it anyways. I have a bunch. This is all pre-computed, pre-generated junk from from Visual Studio. It's what you need to program in a Windows GUI, essentially. So it'll have particular timer events. It'll have a handle to an instance of the window. It'll have some timer information. It'll have callback information, that sort of thing. But the big takeaway is this. Here is me making a new window. This is my main method. It will load stuff in the window. It'll initialize the window. And then afterwards, it will keep on getting messages from the system and essentially dealing with those messages. Again, you don't have to write that. That's given to you. When I'm dispatching these messages, it'll just jump down to, so that's initialize one. This is for when I initialize my instance of the window. Here it is on the Windows processing callback. Every single time I get a message from the system, this thing gets called. So anytime there's a mouse event that goes off, this thing gets called. Every time a window gets created, this thing gets called. When I minimize, this thing gets called. And so I have some kind of message. It's just a number, but some kind of message, whether it's a command or some timer event went off, or a left mouse button was down, left mouse button was up, the mouse was moved, a paint call was called. So if the system is saying, hey, repaint everything, I'll get this thing. So every single time any old event comes in, it comes into this one centralized place. There's another main method, but this thing just sits around and handles every time the system gives you more information. It says, hey, by the way, paint everything, and this is where it handles it. When it says, hey, the mouse was moved, this thing handles it. Everything just goes through this central point. And I'm just checking to see, like, oh, by the way, so if you click exit, what happens? Well, I destroy the window. If I ask for the about box, what do I get? I pop up a dialog box. Right? If the timer goes off, I handle a timer event. Or if paint is called, I get the handle to the device context. Yeah, that's a whole other thing. The big image that I'm going to be drawing onto, that's the device context. Big old image that I'm drawing onto, a big canvas of image, of pixels, essentially. And then I'm just going to, but then what I did here was I said, okay, no. We're going to handle all of this stuff in its own class, this canvas class. So every time I paint, I send something to this object called the canvas class. Every time I have a mouse event, I send it to the canvas class. Every time I have anything that involves specifically like this model view controller stuff, I send it to the canvas class. When I'm done, I kill my timer, I post a quit message, and I break. Okay. So let's have a look at what this on mouse move, where is that? That's going to be up here. When the mouse is moved, I get this event. I check, I go, hey, canvas class, you have a move. The mouse has moved. I send it to the canvas class. Essentially, I'm just redirecting all the messages over to this other class. Why? Just because I don't want to deal with all this Windows stuff. This thing my canvas class is a more generalized approach. It allows me to abstract away what's happening. So every mouse event goes through the canvas class. Every timer event goes through the canvas class. What is this canvas class? So let's have a quick look at the canvas class. MVC canvas.h. The canvas class is refactored. It has already been refactored, actually. I have a model. I have, where's my view? Is that my view? Oh, that's my constructors. Okay. So I have a model. I have a view. I have a controller. Wait, I have a model view controller thing again. And in fact, this MVC canvas has my model, my view, my controller inside of it. And all I do is redirect it into those 3 different piles. If I'm at, with a paint message gets called, I send it to the view. If a model, the controller, some kind of like a mouse event happens, or something, a timer goes off, I send it to the controller. So I can paint everything. I handle mouse events. I handle timer events. And I'm just calling these other classes. It's just a wrapper, something that covers up the fact that there's 3 different classes all working together in there. And I just wrapped it up and covered it up. I put a blanket over top of it. So I have 3 different classes. I abstract away that idea by just saying it's all within this one class. And every time any kind of event happens, it goes through this. Okay. So now that I have that, so I have this way of abstracting away what's going on. I have a model view controller. The view and the controller both know about the model. The model doesn't get called directly. It just stores data. And every time I have a paint method, I can get information. So let's have a look at the canvas class in action. Okay, I'll go down all the way to the bottom to where here is my MVC canvas class, right? This is, I said, this is my view functions. Here's my MVC canvas class. Okay, I set the model, that's do nothing, set things up. When I call paint images, I ask the view to paint images. I just redirect everything through. Okay, on a mouse event, I tell the controller, hey, the mouse event happened. Okay, that's not so fun. Let's look at what paint images does, or where it is. Here's the views version of paint images. So a paint message is coming in, it goes to the canvas, it goes to paint, it goes to the MVC canvas view, the view of everything, and I handle painting. So I have what this thing has is it has a bunch of different views for every single shape. It has views, all the different views, every single shape that I have, there's a view for it. And I just say, hey, by the way, so I take, there we go, here's my paint back buffer. Oh, this is something you don't have to necessarily know about. This is me avoiding a flicker effect. This is not something you needed to worry about. There we go. Again, honestly, you don't have to worry about those things. Just looking for some on mouse event and on timer event. View, paint back buffer. There you go. So when I go to paint things, I draw a white background. So I fill in a white background, and then I have a whole bunch of these views, and I say, hey, shape view, draw yourself. Hey, shape view, draw yourself. Hey, shape view, draw yourself. One shape at a time. They blindly just call paint on themselves, and that's it. So the view has the canvas view has a whole bunch of views. Every time I make a new shape, I'll have a model, a view, and a controller for each one of those shapes. I can just ask each of those shapes to draw themselves. Okay, and that is the grand total of everything. This is me drawing the highlight rectangle over here. Okay, what else do I have? On a timer event, I say, hey, go to each of your controllers that you're keeping around. Tell them to handle the controlling. So I get a controller and I say, update the time. That's it. Just handle a timer event. So, or a mouse event. Every time the mouse moves, I go to each one of these. I go to each one of, this shouldn't be that. Let me see here. Oh, it's me hacking things a little bit. So I get the shapes. I can get the models directly if I wanted to, but I can get the controllers. Here's my various controllers. And all I should be doing is each controller, update your mouse. That's it. So each time I have the mouse move at all, I go to each one of my shapes and I say, hey, check to see if the mouse moved for you or if the mouse affected you in any way, shape, or form. So I go through all my different controllers and they will update themselves. And again, the views that I have, all the shape views, all the shape models, shape controllers, so all the ways of handling mouse input, all the ways of drawing things, they all know about their central model. They all know about their model. So having essentially 3 objects that I consider one object, and all I'm doing is telling the view or the controller what has happened, and they just blindly do things. I've been talking for a bit, so let's see if I can unpack something in here. So what your job for assignment 5B, your job is to take what we're doing with this model view controller, and I've already done it for triangle 2400, right? I have a model, a view, and a controller. But if you look at, let's see here, rect 2400, I just got one file, nothing, right? I don't have this model view controller approach. I just have the model that does everything, which is why, by the way, if I run this again, just to remind you. So this is the canvas class here. Every time I do a drag event, I will make a new shape. That shape is kept around, and every time a mouse event happens, I call the shape controller. Every time for all of the various shapes. Every time I'm supposed to redraw something, I tell each one of those shapes to redraw themselves. Drawing, mouse events, and data are kept separate. They're in separate classes. They're separate concepts. And by keeping them separate, it means you don't go nuts, because there is nothing worse. Everyone always thinks this is, this is silly. Why are we doing this? Until they hit why we do this. Effectively, if you're rendering at 60 times a second, you're having a new paint method, a paint call 60 times per second. You should not be dealing with logic. You should not be dealing with mouse events. You'll be driven nuts if you mix those things up. You have to separate your concerns. Otherwise, you will never be able to reason about your code sufficiently. That's why we do it. We want to the paint method never changes the data. When I'm painting, I am never changing data. I'm just blindly painting. When I have a mouse event, I'm never worried about how it's drawing. I'm just updating information. And the model just doesn't worry about how many times it's being painted. The model doesn't worry about how many times this is happening or that is happening. All it does is it keeps track of the data. If you keep those responsibilities separate, you get a sort of a divide and conquer. Like when you do course projects, which you shouldn't do, but you do it anyways. You do a course project and one person says, okay, I'll take questions 2, 3, 4, you take 4, 5, and 6, or whatever the case is, right? Or I don't know how to program, so I'll write the document and you write the code. We don't ask you to, we really don't like you doing that, but people do that. You're doing what we're doing here. It's a model view controller. You separate concerns. So here is me making a generic, this is a rectangular shape, but in fact, it's actually, I'm not drawing things correctly. That's why it's not showing up properly. When I refactor this, it will draw correctly. That's the problem. I'm using the shape class's generic painting method for the view, which it shouldn't be. It should be a rectangle, a special rectangle. It should be something like that, right? I did a model view controller for the triangle and now that works. But if I don't have a rect view or a rect controller, it doesn't work correctly. So what I really want is every single, like for the circle and for the rectangle, I need to break it into a model view controller. All it is you moving around functions, moving things into other classes. It's refactoring. You're not writing the code. You're just moving stuff around and then rehooking things up to make sure it still works. And the triangle's already doing that. It just, you do it for 2 other classes. Okay. And let's see what other thing. Oh, and here is what should be a circle. Oh, it's not a circle. I'm getting the generic shape, not a circle. I'm getting the generic shape. What I need to do is refactor the circle class. Right. Does that answer? Hopefully that answers questions, but maybe it doesn't. I've been talking for a while. So can I unpack something? That was a fire hose of information that I just threw at you. So can I unpack any part of this? It's also covered in the other videos as well. I just want to make sure that people are feeling just, it's not yet another exposure to how all of this stuff works together. So my one class that I would consider like a rectangle shape or a circle shape, instead of being one class, what I want to do is I want to remove this, plop it into another class called circle view. I want to, let me see here. Do I need to do anything special about the mouse method, the controller? No, actually the mouse events and the timer events, there's nothing special here. I'm using the generic shape mouse events, generic shape mouse things. So because of that, I don't actually have to move anything about mouse events. How I figure out if I'm intersecting a circle, that's different. The intersection into a rectangle is different than the intersection into a circle, right? One, I have to figure out how far from the radius I am. The other one is, am I inside of a bounding box? And so I will actually have a different method for this. Fine. So I'll need to make a circle 2400 or circle model 2400 or whatever I want to call it, a different class. And I'll have one for, so I'll have one for paint for the view and one for the model. And if you look at triangle 2400, that's exactly what I'm doing. I have one for the model and one for the view. It should be very, very little code. I want to expose you guys to model view controllers, but I do not want people panicking and crying or anything. All right, let's see how people are doing. Okay. All right. Oh, my son is here, just in the way. Okay. Why is the square moving? Because I'm clicking and dragging it. Okay. So, well, my son is talking to me while I'm on the while giving a lecture. Yeah, there he is. Looks just like me. All right. So each class should have a model, a view, and a control. But do I need, so each of those classes could, but I don't need a separate controller for the triangle class. The shape has a controller. I get it for free. I didn't need to make a child class of shape controller. I could just keep shape controller and use it. Oh, you a liar. You don't know what I'm talking about.
Yeah, that is true.
Okay. So that was great. Nice. Great. Popping in and out in the first demo. It may not have been popping in and out. It may have been the dash line. The dash line is where I'm just recording where I clicked and dragged. So it's more a visual indicator rather than the actual shape. The triangle itself was coloring in because I was going over top of the triangle itself. Oh, the square popping up, that was an animating rectangle. I was very proud of that. It's awesome. Maybe it's not awesome. So here's what the animating, this is what I did for the lab. The animating rectangle is this. You mean this thing here? This is, I have a timer going off. All of your demos are going to have this, but I have a timer going off every 0.1 millisecond, every 10 milliseconds or something like that. A timer goes off. And I'm checking to see how much time has passed and what phase of the animation I should be in. And I figure out the math to change the size of my rectangle based off of the timer. How much time has passed since the very beginning of the program, or when I first made this shape, how much time has passed, and therefore what stage of the animation I should be on. And I'm intentionally animating it in and out. I hopefully can fluidly animating it in and out based on the timer. So when the timer goes off, I check to see if I have to update the position or the dimensions of my rectangle. And all I'm doing is constantly calling repaint every single time that the position changes, it shrinks or grows. Anytime that shape changes, I call repaint and I repaint everything. So at 60 times a second, I'm changing the shape, and also at 60 times a second, I'm redrawing that shape. And I can put as many of these things in here as I want. That is the view. The view is actually handling all of that. The timer event is updating the model. That's telling me how long it's been animating for. but the view itself figures out how to draw it. No one else needs to know that. The model just needs to know how much time has passed. So this is me doing a more advanced thing. I could have an animated GIF or any number of other things. This is actually how animations work. I keep track of time and then change things as I go. And tone, I'm recording this, so because I'm almost done. Sorry about that. We were just talking about model view controllers. So tone, we were just talking about model view controllers. I'm recording at least that part of this whole synchronous lecture, and we'll go from there. But this is from the labs, me making an animated rectangle. You could also, it's just easier to do a rectangle than a circle. But I'm just making an animated rectangle because the controller handles when events happen, and my drawing, I don't care how fast it's at, how fast I'm refreshing things. I don't care if it's based on mouse events or if it's based off of anything else. The model just has to keep track of the time, and the view just blindly draws stuff. It doesn't care how that time is being updated. It doesn't care what kind of events are causing this to happen. It just needs to know essentially what percentage of the animation I'm in. That's all it needs. And so I separate my concerns: how to draw stuff, how to store data, how to handle user input or keyboard events or mouse events or events based on timers. I wanted to do one other thing just in case you thought I was, if anyone that's, for people that were my student in the past, you may not, maybe you remember this. I don't know. I'm hoping you remember it. Here we go. Okay, and I'm looking for something very in particular here. I want to look for a mouse event. So start. Okay, on mouse event. Okay, maybe it was on the previous. Maybe it was in the previous part. No, there it is. Anyone recognize that? People, just in case you've forgotten or purged it from your head, we were talked about in 1400. We talked about using bit flags, and I said they actually do come up in C. They're actually very, very common. People think, oh, it's full of crap. Why do we need to know this thing about bit flags? There it is. I can store all of this flags thing. It's a D word. It is a double word. It is 64 bits of information. It should be 64 at least. Bits of information. And every single one of those bits, of those 64 bits, can be turned on and off, and they indicate something else. They indicate whether the left mouse button is down, the control key is down. I actually have one of those examples in Shape Factory. Shape Factory, by the way, is when I make one of these objects, I say make a controller, and by the way, here are the flags that I'm using. Make a view. Here are the flags I'm using. Here's my favorite one. Make a model. Here's the start point, the end point, and the flags we're using. And the point is, you don't want to know what kind of shape you're drawing. Somebody else needs to know this, but the Canvas class shouldn't know that there are multiple different types of shapes. It should just say, I'm going to make a shape. So the factory builds this thing, spits out a shape, but the canvas is blissfully unaware what kind of shape it is. It doesn't need to know. So it could be a triangle, could be a rectangle. It doesn't want to know. It just wants an array of shapes and just calls paint on all of those shapes. So a factory method or a factory class makes shapes. So when I say make a model, it will make a model, a Shape 2400 model. But depending on what kind of thing it is, I check to see what kind of shape I'm drawing, and I'll make a circle, a triangle, an animated rectangle, or a rectangle. That's where I make my new views, my new shapes, my new whatever. More importantly, if the shift key is down and the control key is down, make an animating rectangle. If the shift key is only the shift key is down, or shift key is down, I didn't go in the other branch, make a circle. If the control key is down, make a triangle. Otherwise, make a rectangle. Bit flags. I can represent with one D word, with one variable, I'm actually storing 3 different things, more than 3, but I'm seeing if the control key is down, the shift key is down, or if I have a left click. Actually, I don't even check if I have a left click, but I could. Is it a left click? Is it a mouse click up? Is it a click is event? I can store a whole bunch of different things with one variable. That's why we use bit flags. Okay, just in case anyone didn't believe me that bit flags were used. This is not me making this up. This is coming straight from Windows. I wrote the code to make it work, but this is what Windows is expecting of me when I'm making, when I'm using their flags variable. Okay, let's hopefully that, okay. The animating one, great. So that's clear as mud, right? Let's stop sharing it for a second. Can I answer anything else for you guys? I'm going to start making supper for my kids right now. So, because one of them already walked in, that was exciting. So can I help with anything else about model view controllers, objects? We also have office hours throughout the week. Make sure you're asking for help. I know that it's cliche for me to say this, but it's very, I'm used to people asking for help. And then people are like, what, you want me to ask you for help? I'm like, yeah, I do. I'm expecting it. I'm not expecting you to know this, but right off the bat, you have to actually practice. And that requires asking for help. That's why they pay me. Not well, but they pay me. So please, I'm joking about that. So please ask any questions you have throughout the term, throughout the rest of the term. If there's something that's confusing you, if model view controllers are confusing you, whatever the case is, I'd rather ask people asking questions early and me helping them answer them than finding out at the end of term that you didn't understand something you just were afraid to ask. All right. All right. I'm going to leave it there. We're probably going to view model view controllers again afterwards next week. If anyone shows up next week, I'll just remind everyone. And we'll try and pin it onto the Discord server and making sure everyone can see it. All right. Thanks, everyone. Talk to you later. Okay, perfect. Thanks, Stefan.